Dave Peitzman, DJ Technologies. I'd like to show you an infrared gas analyzer we've developed for the biotech industry. This analyzer will continuously measure and record methane, carbon dioxide, carbon monoxide, oxygen, plus it has 6 additional inputs for sensors of your choice. This is a PC-based instrument. All the data is saved in an Excel format. This is ideal for digesters, fermenters, algae applications, and if you put a hydrogen sensor in there, it's ideal for syngas too. Let's come in for a closer look and put it through its paces. We're running this on a Dell laptop, and we have 3 icons that we're concerned with. This first icon is ComCheck. It's just a simple utility to confirm that the gas analyzer and the computer are talking to one another. And if we click on the second icon, this actually starts the analyzer. There's our startup screen. We just heard the valve click. This is the sample zero gas valve. Down in the lower corner here we had our searching eyeballs, which functions as a weight indicator. Once you hit the blue screen, completely forget about the mouse or your touchpad because this program is keyboard controlled. We're going to select number 2, which will be the data logger. We go straight to the data entry screen. The first entry here is our duration. We can do an automatic shut off up to a 3-hour test, or in most cases your test will probably run longer than 3 hours. So in that case we'll put 4 nines in for the duration. 4 nines up there for duration overrides the automatic shut off, so it will run continuously, and this will collect data for literally weeks on end. For demonstration purposes, I'm going to put 5 in here for the interval. This interval is the recording interval. We still have data continuously being displayed on the screen, but we're only going to record data for every 5 seconds. You can control your interval down from anywhere from 1 second out to every 15 minutes. If you're going to do 1 second, this gives you some really nice graphs in Excel. Or if you're going to do a long-term test, it's suggested that we put 360 in here for the interval, and this will give you 10 readings every hour. That way you can look at the number of recordings and you can tell how much data you have, how long you've been testing. For the file name, we're going to put in DVD. You can create your own file name, of course. There's 7 characters there. Also on the file name, if you use a file name that you previously used, the new file will not override the old file. The 2 files are appended to one another, so you will not be destroying any older data. From here we can go on to the actual gas entry screen, or actual gas data screen, so to speak, and with a page down, or we can advance through this data screen and add a name and address and some specific information. I'd like to call your attention to the comment line down here. We have 3 lines of comments with 35 spaces per line. This is where you can put in notes and comments for the specific test that you're doing. This way you can keep your reports straight. I'll hit page down to go on to the next screen. It asks us if we want to, what drive we're going to put it on. We're going to do C drive for the data, and it tells us, it's reminding us that the file already exists, so we're going to append this data to the original data that's in there. We switched over to the gas analyzer screen. We have a flag where the analyzer is pumped and started. We're going to run fresh air through the sample chamber to start a reference. Also, while the thing is zeroing, across the bottom we have 5 entries. These are for the expansion ports. This one is a counter. It's an actual a digital pulse counter. The rest of them are voltage input. While we're waiting for this to zero, the pump has a flow rate of 4 liters per minute. That's the rate at which the gas goes through the analyzer. You may have some applications where this is entirely too much flow and too much sample. You may not even have that much sample. So all analyzers have a bypass port on them, which is a port that gives us direct access straight into the sample chamber, bypassing the pump, bypassing any filters. This is particularly useful if you're short on headspace in your in your test sample, and this way you can use the pump to zero out the analyzer, turn the pump off, and then hook the analyzer up to, say, a peristaltic pump, or in a case a month ago, we didn't even have enough headspace for a peristaltic pump. We ended up using a 60 cc syringe and injected the sample directly into the analyzer using the syringe. It only took 2 loads from that 60 cc syringe to completely fill the sample chamber and the rest of the sample system, and we got very accurate information. So here we've just come out of the zero cycle and we're ready to flow gas in here. I've got this connected to a methane carbon dioxide tank. And before we start the gas, we're going to start the recorder, which is F1. We'll open the gas valve. We also have inputs down here on our expansion ports. This one down here in the corner is a frequency counter. I've got this hooked up to a light to frequency sensor, and as you can see, it's giving us an indication of the light level that's in here. And if I cover it off, why, it drops. So we also have a temperature sensor here, and this input is connected to a battery. All these entries, we can change the position of the decimal point. We can also change the identification at the top of them, depending upon what sensor you have in there. So, also note we have a L reading here. This is lambda. It's like an air-fuel ratio. Probably doesn't mean a lot when you're working with methane, carbon dioxide, and oxygen, but it's a mathematical calculation based upon those 3 values. And if lambda remains the same number, the rest of the values are going to be the same also. So if lambda is stable, the rest of your gas readings are stable. It's strictly an arbitrary number. Let's purge this, and we'll go back to the and check our data. One other thing before we do that, we have a voltmeter hooked up to the output of the carbon dioxide channel. Each one of these channels has an analog output, runs 0 to 10 volts. This is so you can tie it to a PLC or possibly a chart recorder, whatever you need. So anyway, also these outputs are scalable. So a small change in gas value will give you a large change in voltage swing. We run our pump, purging the system, and as you can see, the carbon dioxide is dropping off rather substantially, and of course the voltage is dropping off too. I'm going to return to the desktop so we can look at our data that's saved in an Excel format. And to return there, I'll hit Escape. Escape always backs you up in this program. Now, number 4 is exit the program. We're back on the desktop, and we'll take a look at our data in Excel. There's our Excel display. We have a time and date stamp for each entry. We have our gases through here, and over to this side we have the information from our expansion ports. This will give us our light level and our temperature and the voltage on that battery, or whatever sensor we happen to have on there. Again, if you save two files by the same name, they're not going to destroy one another, so the files are appended to one another. Let's go back into the program again and we'll take a look at the calibration feature. There's our blue screen. Again, we forget about our mouse and we're keyboard controlled from here on in. To enter the maintenance menu from the main menu, we hold Alt and hit M. This brings up our maintenance menu. Gas Calibrate's at the top. We'll select Gas Calibrate. We'll select one step. Gas calibration values are based upon 10,000. So for methane, I have a 70% tank. 70% of 10,000 is 7,000. So I enter 7,000 here. I also have a 30% carbon dioxide concentration. So 30% of 10,000 is 3,000. Also note we have a carbon monoxide channel. I don't have any CO in my tank, so if the gas isn't there, make sure I put 0 in there. Whenever you put 0 in a gas value, the calibration menu ignores that value. This is so you can calibrate the analyzer either using a single gas or a blend. We hit page down to continue. The analyzer goes through the 0 cycle again. The pump starts. We have the 0 flag during the 0 process, so you know what the analyzer is doing. 0 cycle runs about almost 2 minutes, so we finished the 0 cycle, and now we have a flag that says open calibration gas tank valve, and press any key to continue. I'll open the valve, flow the gas, and hit enter. Now it's telling us that we are checking our calibration gas. We're flowing gas into the analyzer. Now we have another flag that says calibrating the analyzer. That's a good flag. And finally we have a flag that says calibration passed. Close tank valve, and press any key to continue. After this flag, make sure that you disconnect the tank from the system. And of course, close off your valve on your calibration tank. The analyzer was successfully calibrated. Also, it's generated a calibration report that's gone on the hard drive. So this will give you a pass or fail message, and this calibration report is useful, so if you should get a calibration failure, you can go back and look at the report more often than not, you entered the wrong gas value on the calibration menu. Again, escape always backs us up. A couple other things I'd like to cover before we close off. This is an infrared analyzer, and right here we have a sample chamber from an infrared gas analyzer. As you can see, we have our ports, our input and our output ports, and this has sapphire windows on it, and you can the beauty of the infrared is that it completely isolates your detectors and your IR sources from sample gas that's in the analyzer. So if you have a corrosive gas, or if you have moisture, or if you have contaminants or particulates, the sample chamber completely isolates this from the detectors and from the IR sources. So this is where you're getting your rugged reliability. Should you get contamination into this sample chamber, you can take it apart. These end caps unscrew. You can clean the sapphire windows, and you can have it up and running and going again probably within a half an hour. With this analyzer, the PC is the operating platform for the analyzer. This addresses your maintenance issues, so if you have a problem with the PC, you can reload the software on another PC, you're up and running and going again. Also, the software is licensed to the analyzer. It's not licensed to the computer. You can have multiple copies of the software running on multiple computers. I've got a number of universities that are using these. They have labs on different places around campus, and they have the program loaded on those computers in those labs. So when they go from point to point, all they have to do is carry the analyzer. They don't have to mess with the computer. I think that pretty well covers it on this analyzer. If you'd like some more information, send me an email at dj@earthlink.net. That's DEJAYE. I thank you for viewing.